Hello, folks. Welcome to Rational Science. We got a great day today. The other day, I talked about the fact that I turned 70, 7 decades. I hope everybody can hear me okay. Please let me know otherwise, okay? I'll see if I can keep one eye, my right eye, on your comments as much as possible. Anyways, I turned 70 the other day. I said that. And I was researching the Plantagenets, the kings of England these days, and there was not one of them that reached the age of 70. The one that reached the highest was Elizabeth I. She reached the age of 69. And then it wasn't until George II, 76, and his son George III, 81, that was already going into the 18th and 19th century. But before then, people really died relatively early and not always in battles. It was like old age was like 49, 54. People died at those ages. So I guess in that sense, we can consider ourselves lucky today that a lot of people live to the age of 80, so we have long lives. Okay, we've managed to extend the lives of individual humans. Anyways, one fella, I complained about arthritis the other day, and one fella made a comment about that. He says, if you want healthier fingers, uh, consider the difference between the animal oils and plant oils. Clocks don't magically age you by ticking. Okay, the clock does not make me age. Okay, yeah, I got it. And oxidative stress ages you, and in every case of stress, your body, while it's still alive, is trying to heal itself. We have all these experts today. Everybody's an expert in medicine and in politics because it's all opinions. So everybody's an expert on their own opinion. Yeah. The way I look at it, this uh, arthritis is a disease or ailment, you could say, of old age. Okay, it's old animals like me that catch arthritis. Some catch arthritis, others catch, diabetes, cancer. Those are all diseases or ailments of old age. And I think a lot of that has to do with the fact that we're living to greater extent today, one. And the other one is that, genetics. I think it's got a lot to do with the fact that we've been inbreeding for the last 200, 300,000 years. There is today no important, no relevant genetic difference between any human. We're all clones, pretty much, in many ways. So whoever you marry, that's your sister, and vice versa. Girl marries her brother. Uh, so I think that's got a lot to do with these problems, and also with why we have some of the problems that you see out there, like homosexuality and autism. A lot of kids being born with those things. And I think it's got a lot to do with the fact that we've been inbreeding for so many centuries, thousands of years, really. And these are the results. And I talked about that in the past a little bit. The Amish, they've been inbreeding for the last only 350 years. They started out with, what, like 3,500. Today they're 1,000 times as many. There are 350,000 today, 100 times, I said. And they all came from that original stock. And they're having problems today as well. They're being born with 6 fingers. Okay, so I think inbreeding has a lot to do with it, and inbreeding leads to problems, genetic problems. And I think that's what we're seeing today in our populations. Anyways, here's the Russians, the Duma, which is the Russian Congress, talking about homosexuality. They decided to do a little more than just ban it for propaganda for kids. Now they don't want it even as propaganda for adults. Okay, and so here we have one note from the BBC. It says Russia passes answer to Blinken gay propaganda law. They call it the answer to Blinken because Blinken, Secretary of State, he said that it was designed to censor people. Okay, and so Russia essentially bans the propaganda of non-traditional sexual relations, categorizes any positive depictions of same-sex relationships in mass media or advertising under the same umbrella as distributing pornography, the promotion of violence, or stoking racial, ethnic, and religious tensions. Bans advertising of anything related to LGBT, prohibits discussions online about LGBT topics and the sale of goods with LGBT slogans or symbols. Anyone who breaks the law will face a fine of up to $6,600, and companies could face up to $82,000. Foreigners and stateless people risk being imprisoned or expelled from Russia if they do not comply. I think there's a lot of Christian denominations in the West which would like to include that in the U.S. Constitution if they could, you know. So I don't think it's just the Russians, you know. But we do have a polarized world in that sense. We have the American Empire and all its colonies, and they've already accepted homosexuality and promoted, in fact. And the other side, the Russians, the Arabs, I don't know exactly about the Chinese or the Indians, but in general, the other parts of the world, Africans, you know, the whole continent, they're not too much in favor of that. In fact, some countries still punish it by hanging or death. Iran hanged a couple homosexuals some time back, saw the news. So, you know, you have this bi-world, this bipolar world. We'll see what happens with all that as time goes by. Anyways, I'm going to start Extinction today with my a little, I guess you could say it's a summary, historical summary of how I see the progress of the global economy. Okay, we went slowly for many centuries, and then what we did was last 200 years, you could say, global economic, the growth, right, and the total economic output has grown balloon exponentially. Thanks to first manufacturing and today to, you could say, services, even though services, again, is abstraction. It's nothing. It's, I call it unemployment. Okay, so anyone who is doing services is doing unemployment. Anyways, here's my 5 cents worth on it in one little strip there, one little video. And let me turn this on. Here it goes. Okay. Economic growth evolved slowly since the start of civilization, going from agriculture to industrialization and ballooning into services. But we can't grow demographically and economically forever. The balloon is going to pop. And man is destined to fade into oblivion. No civilization of intelligent beings in the universe will ever know that we were ever here. The earth will continue to spin and the moon will continue to run around it until the sun swallows both of them. And the universe will continue on as if nothing. That's the fate that awaits us. That was the fate of all civilizations that ever evolved anywhere in the universe. Okay. So that's my 10 cents worth. Okay. This is what I think we're doing today. This is where we're at. Okay. Again, a quick summary. And it's that we have so many people today that you know, are in the service economy. I would say about 85% in industrialized or advanced nations. And those same countries have only about 1% of agriculture, meaning both in labor and in GDP. Okay, so these numbers more or less reflect also the labor force. And you know what we're doing? We're scratching each other's backs. You know, one guy sings, the other one acts, the other one does internet, and so we're doing all these services that are really unproductive in the sense they don't produce anything tangible. All we're doing with that is just again scratching each other's backs and passing the money around. That's all we're doing. Only when that money goes into agriculture, which is, and by agriculture I mean anything that produces food. It could be fishing, cattle ranching, whatever. The point here is all that money goes into, some of that ends up in agriculture. And thanks to that agriculture, we are alive and we can continue rolling around in circles. Okay? But you know, what happens if, you know, at some point money disappears? And the agriculturalists do not accept money anymore. Well, what happens then? Well, I think what happens then, the whole chain collapses. Okay, so now suddenly we don't have anyone producing or distributing food to the cities, to the people who do services, and the whole thing collapses. Now you might say, well, why would money collapse to zero? Well, I can give you my 5 cents worth again. I'm saying money will collapse to zero because it's being not only devalued every day, but if you look at the last 30, 40 decades, okay, 4 decades, I'm sorry, 40 years, right? You will find that the worker, the proletariat, the person who depends on a salary, his income has decreased in value over time. Yes, we live comfy, a lot more comfortable than the ancient Egyptian pharaohs. You know, they didn't have a pillow, they didn't have a bathroom with a shower, they didn't have, you know, a fridge to cool their beer. um, so we live better. But at the same time, all we're doing is more and more people are just making it barely to the end of the month. They're living one paycheck to the next. And a lot of that has to do with the fact that money is being devalued. Right now, we're talking about inflation, meaning, again, money is losing its value. And you're worried about the United States dollar. You should see other countries that depend on the dollar. Their money is being devalued even faster than the dollar. And the question is, how long can we continue devaluing coins around the world, currencies, right? Uh, until we get to a point where nobody accepts it. Because, you know, what happens, it's not like, you know, the poorest people get uh, lower and lower on the scale. In order for them not to go out into the streets and, you know, break windows and burn tires, the governments, what they're doing is subsidizing them, giving them money so that they reach the end of the month. Barely, but reach the end of the month. So these people, you know, a lot of them don't even have jobs or have semi jobs, like selling, you know, something on the streets. And so here they are, you know, they're they're trying to survive, and the government's helping those people. And as long as those people are helped, you know, they don't go out and do bad things out there. But where's the government? Where are the governments getting their money from? And the answer is from God. And they just put the little machine to work, and they pull out the dollars or whatever money currencies they have. And that's what's happening. And I'm not sure you can continue that forever. Okay. Now, one person has a solution. Thank God we have some economists that come here and pitch their ideas. And here's one fellow, he's got a great idea. He says, we just create new money. Instead of green money, why don't we propose brown money? You know, I mean, after all, money is just money, right? So as a nation, group, or people can start printing their own new money that will kickstart the economy. Kickstart the economy because you print new money. You know how many times we printed new money didn't kickstart the economy? You know what founding fathers did to start the economy? They printed their own colonial script. You know what Hitler did when he wanted to start the economy but had no goal? He printed his own money. Okay, what happens when there is no money? We print them again and start the economy all over again. How hard is it to comprehend? Now, wouldn't you like to have this fellow for an economist, you know, running the country? Yeah, these people think that because you replace green money with brown money, you solve the problem. And they don't realize that, I mean, just giving you an example, take some of these billionaires like Trump or, Gates or whoever. Uh, now they changed the money. What will happen to their holdings? I mean, they have all these properties and bank accounts and investments. Suddenly you change the money, that they lose everything, or the government itself. It's got debts. Suddenly all those debts get wiped out because they're not in green money now. You've switched over to brown money, so you don't owe the creditors a penny. I mean, and let me give you another example. I mean, why don't the governments of the world, every government, just give every person on the planet $1 million? Now that would solve a lot of people's problems, right? Give everybody $1 million. Man, that would solve everybody's problem. Why don't we do it? I mean, if money's just money and money's just money, we change green money with brown money. Let's give everybody money. That solves the problem, apparently, right? Think about it. Anyways, here are people who have a better head on their heads and on their shoulders. I mean, and this is what they say about what's coming in the coming months, right? In the next few months. Here it is. Here's Jeff Bezos. He says the economy does not look good right now. Things are slowing down. You're seeing layoffs in many, many sectors of the economy. And that means you might want to tighten up your budget. And it says if you're an individual considering purchasing, blah, 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 you may want to wait a while. Okay? And so he suggests that you wait because things are not looking good. And I guess he should know he's, up there with the elite, right? He's probably, as many would think, part of the New World Order, right? The Illuminati or whatever, So, I mean, he's telling you, uh, grab a hold of your money. In other words, don't spend right now. Not a good time to spend, okay? Because bad things are coming. And here's another source, an investment uh, outfit, Investopedia. 4 ways to hedge against the next recession. Meaning, when they talk about recession, if it's not almost coming, it's imminent, right? There's a growing belief among economists that 2023 could be the year that the US spins into full-blown recession. And they add, recessions don't last forever. Yeah, they could be followed by depressions. And as I see it, that is usually, or the next depression will be followed by extinction. Okay, so they don't last forever. These people suggest that we're going back to normal in the future. And, you may want to think about that. Are we coming back to normal after the next recession, especially with this war going on, in Ukraine? And there is I've got a little article here. Where is it? I think it's this one. Yeah. It says the EU, European Union, postpones talks on oil price cap as divisions stick. There are differences between the different countries in Europe. They don't know whether to put it a money cap, a dollar cap on oil coming from Russia. And the reason they didn't reach an agreement, they think that maybe if they do, or some of these countries think that if they do put a cap, it could damage the global economy. So we got that on top of, the fact that we already have or are moving into a recession. Okay, so we may be counting our chickens at this point, so to speak, right? Here's another fellow, he's a little more drastic. He says, top economist El Arian says we're not just headed for another recession, but a profound economic and financial shift. And these are all experts. I mean, you can call them experts. They're up there. You might say, well, they're no experts, that you know better. Okay, fine. But these are the people who other people listen to. And so if these people are doomsayers, then maybe you might want to listen to them. It says a recession occurs when a business cycle reaches its natural endpoint and before the next cycle really takes flight. But he said, this Aryan, next cycle said this time won't be one more turn of the economic wheel, as he sees the world experiencing major changes that will outlast the current business cycle. Is the recession going to be followed by a depression? That's the question for you. Maybe it gets worse and not better. Okay? Not that I'm saying it will, but if I had to bet, I'd bet on that side, not on the side that we're going to recover. Especially with this war going on over there, I think that's just going to make matters worse. And here we have another fellow says, I believe the economy is the biggest bubble in world history, says Rich Dad Poor Dad's Robert Kiyosaki. God have mercy on us all. Please don't listen to what I'm going to say next. I would get out of paper assets. In other words, money, like bills, currency, okay? The world economy is not a market. I believe the economy is the biggest bubble in world history. God have mercy on us all. And I more or less see it the same way. I think we're headed not only to a recession, but probably to a depression. And I'm not sure if we're going to come out of that. So keep in mind what this site says. We're due for extinction. It's going to be caused by the collapse of the global economy. These people are saying we're going to have a global problem, economic problem. And so maybe you should start sleeping with one eye open. Okay? One fellow has a solution. He says, we got it. We don't stop increasing population or find some new energy, right? Power source, right? The earth will no longer be able to sustain humans. Okay, he thinks it's a question of, the fact that we have too much population. It just continues to increase. We've got to stop it. Actually, population is already dwindling. I guess he's not aware of that. In other words, our growth rate is falling. And it's falling for several reasons, among them that we've moved to the cities. And what happens then is density-dependent birth rates take over. That's the mode in which we're producing the new generations, the new people, the new children. Okay, and so we're already. He doesn't have to worry about stopping increase in population. It's already happening. Okay, in fact, it's one of the big problems on the one hand, because if you don't produce population, you don't produce demand. If you don't produce demand, corporations have to shut their doors. And if they shut their doors, there's more unemployment, and the cycle continues. Because then people don't earn money, so they postpone or don't have children at all. And again, the cycle's just a wheel there. Okay, we're not going to populate the planet, so don't worry. In fact, countries like Japan and Russia are already on a decline. They don't even know how to get people in there because they don't have any immigration. And Europe, all of Europe, Western Europe, and United States, Australia, Canada, all these countries, they would be in negative population growth just like everybody else if it weren't for immigration. Okay? It's immigration that's fueling the population growth and the economic growth in a lot of these advanced nations. Without that, their economy would be suffering, let alone their population numbers. But after he says a lot of stuff, he says, unlikely we go extinct. So we have all these problems, but we won't go extinct. But he doesn't say why we're going to avoid extinction, because he probably doesn't know how extinction happens. Okay, and that's why, I say always, we got to do 101, Extinction 101 before Extinction 102. So some people think that going back to hunter-gatherers will solve the problem. It will only make it worse. Why? Because for a few thousand people to cook, stay warm, they would need a lot of trees every day to sustain themselves. So he thinks this is a question of, defoliaging the environment, cutting the trees down. This is the way these people think. No, it's got nothing to do with that. Let me tell you what's going to happen if, we go to hunter-gathering. First of all, there's nothing to hunt or gather out there. Okay, I mean, do you see wildebeest running on the highway that you can hunt with your bow and arrow or your gun or whatever, your knife, spear? No, there's nothing to hunt. So you would have to go to the forest and compete, with the bears and wolves, maybe for deer and maybe hunt them as well. But then at some point, we're 8 billion people. And there are not enough wolves, bears, deer, whatever to keep us afloat. So forget about hunting. Anyone who's thinking of hunting, should think twice. In fact, I've got a little summary here. Survivalist without a cause is just a caveman. Survivalists are people who plan to hunt after whatever comes our way comes our way. And a prepper is a gardener. He's without a cause. He's just a gardener. He's a person who thinks he's gonna plow the land after everyone's gone. And he's gonna live, I guess, forever. Reproduce with genes that are already wiped out. And with whom? These guys are probably hermits. The only way you're going to survive if you're in a big family group, people who have, a lot of confidence in each other. But if you're a hermit, you're just going to live out your life, and it's the same thing as if you went extinct. You just go extinct a little later than everybody else. That's all. But the big problem is, when the shit hits the fan, this could be the problem. The problem is going to be defense. You're going to be a farmer by day and a soldier by night. You're going to have to defend whatever you plow out there. And good luck with that one. You got all these people from the cities coming to share in your bounty. You're going to be shooting a lot of people. I don't think they'll understand, when their stomachs are completely empty. I don't think they'll understand, that you can say, let me teach you how to plant. There's no time for that. It's easier to steal, believe me. We did it in the past, we're going to do it in the future. Okay? So everybody's on their own when the caca hits the fan. Okay, here's a couple of people who think that humans are different than animals. This fellow says, your analysis misses the qualitative difference between humans and animals. We're not animals, okay? We're humans. Please don't call me an animal. Humans are going extinct in a uniquely human fashion. Well, I don't know what he meant by that. He didn't put down how he plans to have us go extinct. And again, I don't think he has the slightest clue. Okay? Another fellow along the same lines, he says, over the millennia and in the billions of humans who lived and died, humanity by its nature organized itself and went from hunting to feed itself to manufacturing synthetic meat in the laboratory to feed itself. While the whale, the shark, etc., always do the same things. Okay, again, it looks like he's saying that we're not like those animals. We're different. We evolved. We invented things. We moved around. We changed things. And the animals always do the same thing. The cow always eats grass every day and doesn't complain. You eat grass every day. See if you complain. Man, on the other hand, by his nature, does always different things, which show its evolution over the millennia. Okay, I don't think this fellow knows that there's the cat world. I'll just give one example, and that's the cat world. Okay, and you have these cats. You have these solitary cats like the jaguar, the tiger, the puma, right? Mountain lion. And then you have the lions, and the lions are the only ones that have prides. They have families. They live in a group. And all these animals descended from the same cat sometime, a long time ago. Okay, so they say about 6 million years ago. And I thought this fellow says that animals don't evolve. Well, apparently the lions invented something different than all the other cats. They became social animals. So to say that animals do everything the same way for always, I mean, the beavers always make little houses in the river. Maybe you go back in time, there was a development, an evolution of the beaver, and then, suddenly they started building houses, or slowly they figured it out. So to say that man is the only animal that evolved and changed and etc., think again. Look for examples before you open your mouth. Okay, here's another fellow. He says it's global warming that's going to kill us. The exponential function of global warming will be the end of us. We have a guy McPherson there, fearsome guy, and he's a chicken little. He thinks it's going to be global warming that's going to kill us. And you have Al Gore and Greta Thunberg, and they go around preaching the gospel of climate change. Climate change never killed a single species on Earth. Climate change does not kill species. But, it'd be nice if these people would tell us what the mechanism is. How does climate change get rid of us? How does it wipe humanity out? Okay, that's what I need to understand. And all these people talk about climate change, whether it occurs or not, is irrelevant. We'll concede that it's happening. Okay, no problem. The question is, if it's happening, please tell me how that ends in the extinction of humanity. Okay, that's what you got to explain. That mechanism. Please work on that. Okay, don't just say climate change is going to kill us and we're done. Nah, not by a long shot. In fact, it's never happened. Climate change never did anything to anybody. Well, I'll take that back. Climate change only serves to favor whoever comes next. Okay, so whenever the dinosaurs disappeared, the tiny mammals that were waiting in the wings and expanded with the angiosperms, with the flowering plants, they radiated, and I think climate helped some species evolve faster than other species. In other words, if it was warm, maybe it helped these animals. If it was cold, it helped those other animals and those other plants. That, in that sense, yeah, I think climate plays a function, a role, an important role only in radiation post mass extinction. But it doesn't cause the extinction of species or of whole mass extinction. It doesn't cause that. Okay, so here's another fellow. He says, human instrumentality project is basically real. The elites know we're goners. And I didn't know what that human instrumentality project was, so I had to look it up, and it's got to do with anime. These people get their their education, in Hollywood, okay, Hollywood University. And so they look at these things, they get these ideas, about a futuristic world. And anime is, since it's made by Japanese, it's very gloomy, okay, gloomy doomy, okay. That's why, in general, my notion of the Japanese, lots of suicides over there. So, it's a country that's reached its maximum development, and I'm not sure what you can expect from them in the future. Okay, so yeah, some kind of instrumentality project, not important at all as far as I'm concerned. Okay, just people who think that in this world where they're in the streets and everything's dark, and here you have the couple that's trying to survive in this new world, etc. So it's a lot of novel. It's a novel, but very little on science, very little on analysis, and always, 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 no matter which one of these movies or cartoons that you see or watch, what you will never see is anyone addressing food. You have like Waterworld. It's like, where does the food come from? And you see all these movies, these extinction movies, and they never talk about food. It's like, it's some disease or some age, and it never ends in extinction. By the way, there's always a baby at the end to give humanity hope. Okay. Okay, so here we have, I made a comment the other day that measures to prolong time to extinction. And I said, no more babies, we have to found new cities and shift labor to agriculture. And again, I don't think this is ever going to happen. I'm saying that it would be nice in an ideal world where everybody on Earth, realize that we're due for extinction. We say, okay, we're intelligent. How can we fix this problem? How can we prolong our lives so that extinction doesn't hit us so quickly? And these are the suggestions I'm saying that, people would have to zero in on in order to extend their lives. For humanity as a whole, right? And that's if we all cooperated, if we all loved each other, if all the governments, were had no politicians, no lawyers, No, if we were all, Buddhists or whatever, Hindus, and embraced each other, well, this is maybe what we should do, and this is the only thing I can think of that could prolong our lives. But a couple of people say, why would you want to do that? Prolong our life. Another fellow says, why would we want to? People stink. Convid taught us that. Okay, I guess he misspelled COVID, right? Okay, so here's another fellow along the same lines. He says, so you're saying a Maoist land reform could work? Laugh out loud. Why not babies, though? I don't quite understand that. Are you saying humanity should reproduce slower to make the genetic diversity last longer, or just letting it be the last generation? No, I'm saying that, if you look at the map, it's terrible. We're concentrated in cities. If you look at the world, it's mostly urbanized and becoming more and more urbanized. That means we're expanding the existing centers. And I'm saying there's a lot of free land out there. Be nice if by some miracle, God's miracle type thing, that we could induce people to leave the cities, go to the middle of nowhere, in the middle of the desert, right? In the middle of the forest, jungle, wherever, and found new cities. So they create this new cities, right? With whatever they've got there. If they do primarily agriculture, they're creating real stuff, right? And hopefully they can become self-sustaining, even export, whatever. But the idea is to create more cities. But then at the same time, I think we should stop procreating, because the more we procreate and the more we stay in the cities, that's bad. We should go out into the country, and the existing people should go there. And stop procreating only because, we realize under this context, okay, the context is important here. We realize that we're the last humans on Earth. Why are we going to produce more and more children? Okay, the idea would be to limit now the number of children that we have in the world, so that whoever is young today just grows old. Okay, and we all try to live together, kiss each other, be friends and family, etc. Of course, I'm talking about a world that doesn't exist. I don't even think it exists in heaven. Okay, but I mean, this is what I'm suggesting. That's my solution, my 10 cents worth. Of course, it's not going to happen, but I'd say that that would be an ideal world where we say what could be a solution. Solution would be to found new cities in the middle of nowhere and do it with the existing people. That's my point. Okay, and so I always recommend that we do Extinction 101 before you do Extinction 102. Everybody wants to do human extinction. Everybody's an expert in human extinction, of why man won't die or why he will die, and he will die in gazillions of years in the future, so we don't have to worry about it. No, please do Extinction 101. Find out how extinction occurred in the past, in the days of the dinosaurs, in the days of the Triassic archosaurs, in the days of the Permian mammal-like reptiles. Once you figure that out, you can tell me exactly how all those animals disappeared, then we can talk about human extinction, okay? So that we can extrapolate whatever you found in those days to humans and see if we can overcome whatever they couldn't. Okay, let's move on to the subject matter of today, and that is particle. What is a particle? Does anybody know? I've been searching for this thing called particle, quantum particle. Okay, we're going to talk about quantum particle, by the way, okay? And maybe that's where we should start. Here we have the notion that laymen have about what particles are, okay? And I guess they extrapolate them, or most of them apparently extrapolate them to quantum mechanics. And it's the classical particle. And what is that? Well, it's a grain of sand, a seed, a speck of dust, tiny ball, corpuscle. That's what we used to call them, right? And right now, quantum particle, the answer you get from the PhDs, the Nobel Prize winners, and all these other good people, we don't know. So please don't ask. And you say, Bill, you're kidding me. No, no, I'm not kidding you. I'm going to prove that to you today. I'm going to show you some evidence, okay? Evidence, proof, okay? I'm going to show you today that that's exactly what the PhDs are telling you. Please don't ask because we have no clue whatsoever. You say, well, holy, a particle is a particle. I mean, we represent it in the old days, right? In classical physics, meaning anything below 19th century and below, right? And that was the dot, the ball is a spot, point. You would hit the board with your chalk. You make a little white dot and say, that's a point. And what is that? That's a particle. And everybody would understand. You could explain your theory by saying, look, that dot now moves over here, moves over there, and I can explain this motion, that motion. That's more or less how it went. And it turns out that quantum explains it the same way, except that they tell you that they don't know what it is. No longer do they say it's a grain of sand or a tiny ball. In fact, they specifically tell you in your face, it ain't. It's not one of those. So don't insist. We don't know. Okay? That's the answer you get today. And so we say, well, holy, how difficult can this be? So let's look it up first to see if there's some kind of definition out there, for what a particle is. Here's one definition. It comes from a source, a trusted source, right? The AMS Glossary of Meteorology. An aggregation of sufficiently many atoms or molecules that it can be assigned macroscopic properties, such as volume, density, pressure, and temperature. Now, how's that for an answer? So it's a bunch of particles, right? Forms, I guess, a ball. This is what I illustrated. Maybe it's a cube, I don't know. But I illustrated that as a ball, and a particle is just a bunch of particles. Okay, that's what it is. Okay, did you understand? Particle is a bunch of particles. Okay, that's great. Okay, let's see if we have any other version here. We have the Wikipedia. As always, we should use primary sources that all these PhDs put their 2 cents worth in there, and then they later disclaim it and say, well, don't trust the Wikipedia because it's got all these terrible definitions. Turns out that all those are made by PhDs, especially in the world of so-called physics, mathematical physics. Okay, so this is what you find in the physical science. A particle or corpuscle. Corpuscle is a particle? I thought it wasn't. In older texts, is a small localized object. So they're saying that the so-called particle is a small corpuscle or object. Okay, so keep that in mind. Okay, this is what the encyclopedia tells you. Okay, to which can be ascribed, several properties. Great. Okay, and so you look up this and you look up, for example, elementary fundamental particle, and it says one that is not made of components. So it's, I guess, made of a single piece. Okay. We'll keep that in mind as well. Okay. But then you look at, what do they mean by object? It says localized object, a collection of matter. What is matter? Any substance that has mass, takes up space. Okay, great. What is a substance? It's matter. Anything that has mass and takes up space. Okay, what is a chemical substance? A material, meaning matter. What is mass? Quantity of matter. What is space? Well, we still have no idea today. At mathematical physics, right? Has no idea. So we don't learn much with these definitions because they use the word object and maybe they might use the word entity, right, to depict or define the particle. And no, they're wrong. It's not an object. We'll see that today. Okay, not a thing. And that's why they tell you that they don't know what it is. Okay, here we have an article. Was from 2020, I think it is. Let me get this smaller. And it was from the Quantum magazine. And these people, give me a second here. These people say that, ask the question, what is a particle? And they didn't just ask it, they decided to ask all the so-called physicists, mathematical physicists. Okay, and give me one more second here. Jeez. Okay, and it says, what are particles? The easy answer quickly shows itself to be unsatisfying. What a bad way to start your presentation. And it says, I'm not going to be able to tell you. Okay, electrons, photons, quarks, and other fundamental particles supposedly lack substructure or physical extent. So it's an object that has no shape, no size, no diameter, no radius, no nothing. There's nothing there. You can't illustrate this so-called particle, and none of these, electrons, photons, quarks, because they have no size. What are you going to put in there? You can't put a dot and say, well, assume this is the electron. You know, I can't make that assumption because you just told me it has no size. Why did you put a dot? You put a heart to represent love. You put a dot to represent point. Well, if you do, you're making a big error. Okay? Okay, and yet particles have distinct traits such as charge and mass. How can a dimensionless point, right, bear weight? Yeah, good question. So this lady decided to investigate this issue and ask all the, let me see if I can get this out, ask all these PhDs, high-level PhDs in so-called mathematical physics, what is a particle? I mean, if they don't know, who does, right? Okay, so here are the answers she got. Okay, she went to different places. You'll see who the authors of these answers were. Okay, here we have them. First one, we basically think of a particle as a point-like object. Again, said the same thing as before. Okay, is that what a particle is? Okay, let's use it. What's the problem? If it's a point-like object, meaning, you know, it's got shape because it's an object, it's got size, it's got dimensions, it's got all these good things, why were they saying that it has none? You know, and then it says, what we think of as elementary particles, again, one that is not broken up into simpler parts, right? Instead, might be vibrating strings. So we have an elementary particle, which is not made of anything, which has no size, no dimensions, right? And, but that's a vibrating string, whatever string is. And what is a string made of? Well, it's made out of particles because the string is not a string. It's a line. It's a curved line. What is a line? It's made out of dots, points. What do they call them? Geometry points? Locations. Positions, as the mathematicians call it. That's what a string is. A string is not a physical entity. It's a mathematical contraption. You can't even call it a contraption because that word is wrong there as well. No, it's just it's a mathematical abstraction. That would be better to say. It's a line, and a line of geometry, a line of mathematics is made out of points, which are locations, positions, right? And means that we're not talking about things. We're talking about dots that represent concepts. Okay, so we are reifying the string, and they say that the string, when it vibrates, is a particle. So a particle is not a standalone thing. You can't take a snapshot of a particle because the string has to vibrate it in order to make up the particle. All kinds of errors with that statement there. Okay, that was by Mary Gaillard, particle theorist at UC Berkeley. Okay, that was the first one. Let's see if we have any more. We have another volunteer here. Her name is Helen Quinn, and she's what? Emeritus professor at Stanford. She says the following, says, what is a particle from a physicist's point of view? It's a quantum excitation of a field. Okay, so it turns out that the particle is something in motion. That's what makes up the particle. They call that something a field. So we have a field, it vibrates, and as long as it's vibrating, we have a particle. So a particle is not a standalone, you can't take a snapshot of a particle because you have to wait for the field to vibrate. There's got to be a verb in there, you know. And so you need 2 frames of the universal movie to make a particle, which is kind of weird, you know. And we look up the word field, and it's a quantity. represented by a number that has value for each point in space and time. So again, we're talking about a number. The number vibrates, and as long as the number vibrates, we have a particle. If the number stops vibrating, I guess it's the number 5. Could be the number 7. So if the number 7 stops vibrating, we no longer have a particle. You figure it out. It says in that there are a bunch of different fields. Each field has different properties and excitations. They are different depending on the properties. Those excitations we can think of as a particle. That was her answer. PhD, what? Emeritus? Okay. These are the teachers that you're paying for in some of these schools, because a lot of them are government supported. Okay, here's a Nobel Prize winner. I mean, you got to pay attention now for sure, okay? Because the other two, they were not Nobel Prizes, just a petty emeritus and so-called physics teacher. This one's a Nobel Prize. Shelley Glashow, okay? Particles are at a very minimum described by irreducible representations of the Poincaré group, okay? The representation is not the particle. The representation is a way of describing certain properties of the particle. Okay, so we're talking about descriptions of a particle. I wanted to know what a particle is, that you could point to it and say that's a particle. I guess you can't do it. And let us not confuse the two. Yeah, here you have a PhD who got his Nobel Prize in quantum mechanics for coming up with some little idea in quantum mechanics, and he can't tell you what a particle is. And quantum mechanics is a particle theory. You know, it's got the standard model of particles. And this fellow, he cannot tell you what a particle is. But he was given a Nobel Prize by his buddies, right? Makes you stop and think, right? Your Nobel Prize doesn't know what a particle is. How difficult can it be? It used to be the famous corpuscle that, you know, Newton had in the back of his mind, and all these other people, all the way to the 19th century, they thought of it as a little dot, a little ball, little seed, little grain of sand. We all understood that, but now, you know, they're talking about what, fields, vibrating numbers. That's what a particle is. And then they take it back and say, we don't know what it is. What did you just say? You said it's a vibrating field. Now you say, well, we don't know what it is. Okay, so it's getting better and better every moment. Here's another testimony. Take these people to court, right? Dmitry Nanopoulos, particle physicist at Texas A&M, okay, Aggies. If you zoomed in enough on particles, you would see not points, but one-dimensional vibrating strings. Again, another string theorist here. What is this thing? I mean, God is better than this. Yeah, you're telling me. Particles are what we measure in detectors. At the moment that I detect it, it collapses the wave and becomes a particle. The particle is the collapsed wave function. The collapsed wave function. What in the world is that? Let's see if I think I have it here. No, I don't. Okay, I'll have to skip that one. But the point is, it's a wave function collapse. So here we have a field that vibrates, and that's what a particle is. Here they say it's the collapse of the wave function. Function is an equation. That's you know, it's a formula, a mathematical equation, and they're saying this thing is going to collapse. So I can't imagine how a wave function can collapse. What sense does that make? What meaning can that have? Okay, I don't have any answers for you there. Anyways, here's another testimony. Another witness comes to court and it says the following. It says, particles are what we measure in detectors. We start slipping into language of saying that it's the quantum fields that are real and particles are excitations, okay? That's how they present it to you, right? We talk about virtual particles, yeah, whatever those are. Virtual means that they come out of the magic wand of the mathematician. but it doesn't go click, click, click in anyone's detector. Okay? Yeah, I mean, you have all these so-called particles, virtual particles, the elementary particles, and what they say is we don't know what it is, but as long as they go tick, tick, tick on the detector, then we call it a particle. And some of them, come in from the void because we have to make them up. You know, you figure out. Jesus Christ. And here you have another fellow. He just says, "Shut your mouth. Don't ask. Okay? Don't ask, don't tell." Okay? We say they are fundamental, but that's just a way to say to students, "Don't ask. I don't know the answer." It's fundamental. Don't ask anymore. Okay? At least that was a more honest answer, I think, than all these people who claim to know what a particle is, and they say it's a vibrating field, it's a wave function collapse, and these people say, look, don't ask, we have no clue. And here's another fellow from MIT, says, at the end of the day, quantum gravity has some mathematical structure, and we're all chipping away at it. Good, if it's got structure, fine, but mathematical structure? That's like saying it's an abstract structure, abstract physicality. like that's an oxymoron, mathematical structure. A quantum theory of gravity and space-time will ultimately be needed to answer the question, what are the fundamental building blocks of the universe on its most fundamental scales? A more sophisticated phrasing of the question, what is a particle? Yeah, but see, they never ask that question in mathematics because they have no use for objects. All they have use for is equations and numbers and measurements and values, quantities. So yeah, it ends the presentation saying we don't know is the short answer. They don't know. So please do not ask that question of a mathematical physicist. Okay, they have no clue. Okay, so when they tell you, look, it's a wave function collapse, it's a vibrating field, say, okay, but what is it? Can you draw it for me? Can you point to it? And hopefully the guy in front of you will not say, please don't ask me again. Okay, so here are the conclusions, folks. We have not a single mathematician on Earth can tell you what a quantum particle is. I mean, is it a physical object or not? If it's zero-dimensional point or whatever, however they want to describe it, we have a nothing in front of us. So you can't say at the same time that it's also a vibrating field and also the wave function collapse. You can't have all these versions. The correct answer is they don't know, please don't ask again. Okay, that's the answer. So a quantum particle is not a tiny ball. A quantum particle is a location with a value. That's what the mathematicians deal with. So quantum mechanics does not have particles, meaning corpuscles, tiny balls. Okay? It is universally designated, represented with a dot. Everybody puts a dot, chalk on the board, pencil on a paper, etc. It's just a dot. And that dot is a physical entity. You see it, it's two-dimensional at least. And you look at it and say, okay, is that what a particle is? Okay, I see, it's just a tiny ball. That's not what you're staring at. They already fooled you. They put a thing to represent a concept. And you didn't catch it. Okay? So the word particle and a pictorial dot mislead laymen into thinking that the quantum particle is a thing. It ain't. Okay? Quantum does not deal with things. Okay, so it cannot describe or explain, especially the universe in which we live, especially the subatomic world, okay? Atomic and subatomic world. This is not a quantum particle. Okay, so anyone who tells you differently, he's lying. Okay, so don't believe him. And so here's the standard model of quantum mechanics. Okay, what do you see there? Well, you see all these so-called particles. They call them particles, elementary particles, particles made of a single piece. In other words, that are not made of smaller components. And it's interesting that they haven't found the graviton. They've been searching for that one for ages. Okay? They haven't found the graviton. and that's the particle of gravity. They will never find it because you cannot explain pull with gravitons. It also is, even if they did find it, it's inconsistent or incompatible with general relativity, which talks about extended fields and canvases, I guess you could call them. So yeah, none of those are particles in the sense of how we imagine a particle, a little tiny speck of dust. In fact, you can see that there are no pictures of any of the so-called particles. And they have little drawings with a little H on top or a little C or whatever on top of them, and that's what they consider a particle. Uh, they have no idea, in other words. They're going to talk about traces, and they're going to talk about wave functions, and they're going to talk about fields, and those are not defined either, at least in any physical sense. So you will never know, you will never understand what a particle is in quantum, and so the particle model, in fact, they should use a different word. They should call it the collapse or the vibrating field or whatever, instead of calling it a particle. Particle is a misleading word, okay? And it's just there to fool you. Okay, we had our science critic, okay? And what did he talk about? Well, he talked about studying. And originally he said, he made a video, by the way, a 45-minute video talking about the scientific method, criticizing the scientific method. And so we address each one of the points that he raised, and especially today we're going to talk about studying. He insinuated in a previous talk that science is about studying. And here we're going to say that it ain't. In fact, we're going to find out that he absolutely agrees with us. Okay, so let me put him on so he's you hear from the horse's mouth himself. Okay, here goes. The question to be addressed in this rebuttal is a scientist someone who studies?
Just so that everyone's aware, that bit that says to study all night is just an example of it being used in a sentence. Well, just because you study something, that doesn't mean that you're a scientist. I have studied computers and audio. That does not make me a scientist. And also, devoting time to gaining knowledge does not guarantee the retention of that knowledge. I think anyone who has sat an exam can attest to that. Nowhere in the definition of studying did it say that you have to do it by reading books. It just said that that's the typical way that it is done.
Okay, so that was irrelevant, that last statement, the fact that you have to do it by reading books. He suggested doing experiments and studying in your own dark basement, etc., etc. None of that has anything to do with science. In fact, here, and he seems to agree because he says that just by studying, you will not learn. And he's totally right. That is the problem with using the word study to define the word science. Okay, that was the issue. Here you have some sciences. The first one I'll mention is biology. Okay, biology, what is it? The scientific study of life. That's the official definition. No, it's not the study of anything. In science, we do not study. Okay, you can study all you want, doesn't mean that you're going to understand. In fact, there you see it, studying, you can study, but you fail on the test. Okay, and so what's the issue? The issue is science, a systematic endeavor that builds and organizes knowledge in the form of testable explanations and predictions about the universe. That's the scientific part of biology's definition. Okay, and you look up these words, endeavor, what is it? Attempt to achieve. Okay, you're going to make an attempt at something. Is that what science is? Making attempts at achieving? Hopefully, science is after the fact, when you have achieved already. And what you have to achieve is explanations. Knowledge, it's belief. Okay, that's what it's defined as, justified true belief. Testable explanations, what the hell is that? In science, we have explanations. Testable means that you're working on belief. You know, you're harping on religion. You're saying, do you believe it? Because you tested something and you decided to believe it or not believe it. Okay? Prediction, well, I don't know what that has to do with science. That's astrology and palm reading. They do predictions over there, foretelling. They can tell you the day that you were born, if he's a good astrologer, or he looked at your driver's license or something. Universe, what is that? It's time, energy, mass, and fields, and other mathematical concepts. That's what the definition of universe means to a mathematician. And a biologist, I guess, follows through on that, on those definitions. So yeah, biology, the scientific, I don't know what that is, a scientific study. No, in science we don't study. And in life, as I discussed in the past, there is no definition of the word life emanating from the biology world. Okay, so we don't have a single biologist on planet Earth because not one can define his discipline, his realm of expertise, okay, has no clue whatsoever. Okay, so until they can define the word life, and if biology is the study of life, right, as they say, well, first it's not the study, but then they don't know what life is. So much for biology. Okay, let's see if some of the others do any better. Here we have, where is it here? Paleontology. Okay. Oh, I got the same one. Well, let's see if I can get, give me a second here. Get the one from paleontology. There we go. Yeah, that's the one for paleontology. The scientific study of life that existed prior to the start of the Holocene epoch, roughly 11,700 years before the present. It includes the study, always that word study, of fossils to classify organisms and study the interactions with each other and their environments. Okay, so they use the word study, 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 study. Is it just study? Is that what paleontology is? No, paleontology is not the study. In paleontology, you have to explain. If you don't explain, you're not a scientist. You're not a paleontologist. And no, it's not, Indiana Jones with his little pick and digging up bones. That's not paleontology either. That's a field worker. Could be, one of these bean pickers out there that, picks beans or strawberries, in California. Are they paleontologists because they dig? Okay, so no, just digging it does not make you a paleontologist. And cleaning bones, right, does not make you a paleontologist. Naming them does not make you a paleontologist. Paleontologist does one thing and one thing only, and that's explain extinction. If you cannot explain extinction in a rational manner, you are not a paleontologist. I'm sorry. Okay? And so far we have no paleontologists on Earth, first because they do study, or they can't define their own discipline, but then they have all these irrational theories of mass and background extinctions. So we don't have a single valid theory of extinction today. Until we do, we don't have paleontologists, I guess, right? Okay, and then the last one here is physics. Okay, the natural science that studies. We do a lot of studying. Studies what? Matter. Its fundamental constituents, its motion and behavior through space and time, and the related entities of energy and force. Let's look up those words. Matter, any substance that has mass and takes up space. What is motion? An object changes, and etc., etc. And what is changed different from what it is or to transform, which in all cases involves motion, meaning the word change is a synonym of motion. You can't use the word change to define the word motion. Okay, space. What is space? The boundless three-dimensional extent. I don't know what an extent is, but certainly space is not three-dimensional. Okay, hopefully not. Space has no dimensions whatsoever. It is a synonym of nothing. What is time? Continued sequence of existence and events. I guess it's got to go to the future, right? Which they say in the definition, but that would take time because future is already a definition of time. Okay? In other words, you need time to define future. So we got a circular argument there. Entities, it says, is something. No kidding. Good. Okay, energy. Energy is an entity. The quantitative property, it says. So how can they say the entities of energy and force? Force, what is? An influence. Sounds like a verb. So we have the quantity, a quantitative property, and an influence. So none of those words help to define physics at all. So yeah, in a way, this shows that all these definitions of these disciplines, they're misconceived. That's one issue. The other one is that, no, we don't study in science. And so this fellow is saying that science is the study of, because that's the definition he found out there. Well, you know, those definitions have to be wiped from the dictionary. Okay. Okay, let's get to some of the questions people asked since last time they posted, or comments. One of the definitions of science is knowledge of any kind. Absolutely not. We have only one definition of science, and that's rational explanations. If it's not rational, we don't care, how much knowledge you have. Knowledge has nothing to do with anything, aside from the fact that the word knowledge has never been defined other than as belief. That's what knowledge is a personal belief. That's all it is. That's all knowledge. When you know, nobody can change your mind. It's because you believe it so strongly that it's like a strong belief. That's all knowledge is. And that's personal. That's your personal opinion. And that has to do with religion. Religion deals with opinions. Okay, so no, we don't care what one of the millions of definitions of science is out there. There's only one, and that is rational explanations. You don't have a rational explanation, you are not a scientist. Okay, the word plasma is knowledge of. Again, knowledge, no, has nothing to do with knowledge. Plasma, there it is, ionized gas, that's what plasma means. Actions of that plasma in the photosphere as coronal mass ejection, solar wind, where it meets the intergalactic plasma, is traveling around the galaxy. You have plasma traveling? How can a concept travel? Does love travel also in your religion? I mean, these people, especially the electric universers, they strongly believe in plasma. They are plasmoids, as we call them. Okay, no, plasma is ionized gas. That's what the word plasma means. Ionized is adjective or a verb, really. Okay, there's motion involved in ionized. There's no such thing as static ionized. You need 2 frames of the Universal movie at least to depict ionized. Okay, you can't depict ionized in one picture. Okay, you can't show the ET in one picture ionized, whatever. Okay, any atom that's ionized needs two frames of the movie. And what is it being ionized? Gas. Gas is an object, is a thing. Okay, why? Because you don't need motion in the definition of the word gas. In other words, the word gas does not involve a verb, motion of any kind. The word plasma does. That's the difference between them. Gas is static, plasma is not. Okay, so that's where these people, and of course they never relinquish the word plasma because their whole life depends on this word plasma. You kill plasma, you rape their virgin. You kill their God. So they're going to hang on to the word plasma till the end of their days. So you can't take it away from them. They're not understanding the logic, and they dismiss that as, word salad, semantics, blah, blah, blah. No, in science, we have to define the word so we know what we're talking about. We have to be on the same page. Plasma is ionized gas. That's what it is. Sorry that you just found out. And ionized gas meaning, just a bunch of atoms. They're not bound as strongly as other objects like, a table or a chair. That's a solid, right? A rock. So those don't move as much as the ones in a gas or in a liquid. But it's irrelevant. The motion is irrelevant. I can take a picture of gas and call it gas because gas, the word gas, does not embody any motion. The word gas does not embody any motion. Do you understand? The word gas does not embody any motion. Yes, the electrons are moving around every single atom in the universe. Okay, so don't tell me that the electrons are moving. No, we take a snapshot And in the snapshot, in the picture, in the still image, in the frame of the movie, in just one frame of the movie, there's nothing moving in that picture. Okay, God just takes a sword, very thin sword, makes a cross section of time across the universe, stops the universe wherever it's at. Nothing moves. Okay, except him, I guess. Nothing moves. Not a single electron, not a single atom, nothing moves. Okay? Gas is that blob that is frozen in time. There is no plasma that you can't point to plasma in that cross section of time because plasma is defined. It embodies motion. Do you understand? Can you get it through your thick skull? Plasma involves motion. Gas does not. I don't know how else to tell these people. They're just so thick-headed that they'll never understand. Okay. Anyways, ionized is what a gas does. Okay. Gas is the object. Ionized is what it does. That's what plasma is. So gas is a photo where plasma is a movie, and that's why you cannot use a concept because it's a dynamic concept called plasma. You cannot use it as a physical object and say plasma does this and plasma moves and plasma went out of the sun in intergalactic space. Not in this universe. Okay. Okay, and then I think same fellow, he says, plasma, a state of matter. See, they have these two definitions for plasma. One is ionized gas, and the other one is a state of the union, or something like that, state of matter. It doesn't matter. One of the four, including liquids, solids, and gases. So he's saying, okay, let's get it right. This fellow, just like all electric universes, they think that a state of matter, such as solid, liquid, and gas, those are not objects. Those are not things. If you say a solid, that's not a thing. Solid is a category. Okay? Under solids, you can put, furniture, rocks, trees, solids. It's a category. You can't say a solid is a thing. Okay? And likewise, if you're going to put it in this context and say plasma is a state of matter, then what you're saying is that plasma is a category, and therefore it's a concept. Okay? It's a type of matter. Okay? And that's not a thing. It's a concept. Okay? I don't know how else to get it through your thick skull. And again, all these people say, Bill, you're doing, word salad and semantics. We need to know what these words mean so we can use them consistently so that we're all on the same page. So it's not word salad. Okay, and I'm not sure how else to drive it through his head. Maybe little, sometimes that works, wonders, Okay, anyways, in this context, solid, liquid, and gas and plasma are categories. So no, you can't use the word plasma as a physical object, whether you use it as a state of matter or as ionized gas. Either way, it's banned as a thing. It's not a thing. There's no such thing called plasma. Okay? Plasma is a concept. You need to learn language before you learn physics. Okay? You need to take English 101, grammar 101. Okay, so here's another fellow says, lightning has shape. Are you calling lightning an object? Sound waves have shape. Are you calling sound an object? Magnetic fields have shape. Are you calling a field an object? Okay. Fields, energies, and sound waves have shapes. There are many examples of physical presence that have shape but aren't objects. Well, I don't know. Lightning, I guess he says lightening. Lightning is not a physical object. No, it's not. It doesn't have shape because lightning is in motion like plasma is in motion. Like electricity is in motion. In fact, I didn't realize that. Lightning is electricity. Yeah, of course. And what is electricity? Can you take a snapshot of electricity? No. We take a snapshot of some light there, and we say that thing is electricity. It's lightning. No, whether you know it or not, that's not electricity. Electricity is defined as something in motion, and so is lightning. There is no such thing as lightning in a single picture. Okay? You can take that as a flash of light. Is that an object? does that have shape? Not if you call it lightning. Lightning, look it up. It's got a verb in it. Okay, it's got motion in it, and so does a magnetic field. Any field for that matter. You have motion. Okay, so there's no such thing as a static field. Fields are all in motion. In other words, something is in motion that makes up the field. And good old Mr. Maxwell, James Maxwell, he said, there is matter in motion in there. Some exotic matter, right? There's matter in motion. What you have to identify is the matter that's in motion. Calling the whole shebang a field, something that's moving, like plasma, calling that a thing, calling that moving thing a field, you don't get away with that, not in physics. Okay? You have to tell me what it is that's moving, and also in the case of electricity or lightning there, you have to tell me what it is that is moving, because something is moving from up down. Okay? And they say, oh, it has shape. No, it doesn't have shape. Shape is a static concept. Lightning is not. Okay, so I don't know how else to explain it to you. If you don't understand it, look it up. Look up these words. You'll find out that you made a boo-boo. You spoke too soon. Okay, fellow says, I don't have it here. Give me a second here, see if I can find it. There we go. An object is a collection of matter. This is what he says. Object is a collection of atoms. Okay? So we look up matter, any substance that has mass and takes up space by having volume. Well, substance is already, an object. Okay? So hopefully, you're trying to define the word object and you're using the word matter, which is substance, and substance is already an object, a synonym of object. Objects that can be touched are ultimately composed of atoms. That's what we find out there in the Wikipedia. And so they're talking about touched. So if you can't touch them, they're not composed of atoms. Like the table on the other side of the universe, that's not composed of atoms. And you say, well, it can be touched. Well, how do you know? I mean, we can't even run the experiment, so how do you know it can be touched? Okay, so this is the issue. In scientific usage, matter includes atoms and anything made up of them. Okay, so all they did was go around in circles. So to say that it's a collection of matter, we haven't said anything. Because matter is already, you have to define the word object before you define the word matter. Because matter is a bunch of objects. That's what matter means. So you can't use the word matter to define object because you have to define the word object before you define the word matter. And to say it's a collection of atoms, well, what is an atom? Isn't it an object? So again, these people are chasing their tails around trying to beat the definition, and they're just going to go nuts. And then you find in the dictionary.com, matter, the substance, again, substance, or substances of which any physical object consists of or is composed. So again, they're talking about they're talking about mereology, what something is made out of. And physical or corporeal substance, something that occupies space. Okay, so again, we're talking about synonyms. Substance is something, something is object, and matter is a bunch of objects. So far, we have no definition from you because all you used was synonyms. Just chase your tail around. And here, another fellow, I think it's the same fellow. There are 4 fundamental forces at work in the universe: the strong, weak, electromagnetic, and gravitational. Well, there's only 2 forms of contact that we can imagine. Okay, and that's push and pull. Okay, so you either pull or you push. That's it, as far as forces. And you got to answer how the weak and the electromagnetic force different from push. They're both push forces, and the strong and the gravitational forces, they're all pull forces. So how are they different if 2 of them are push and 2 of them are pull? So that's what you got to answer. So I think maybe he was referring to not 4 forces, but maybe the 4 horses, like the apocalypse or something like that. Yeah, no 4 forces, only in religion. And here's the last issue. Fellow says, looking at your graviton field, how exactly are your ropes different? That's strange that he would say this, maybe newbie, but yeah, the discrete graviton field, okay, that's what quantum proposes, that a bunch of particles, discrete particles, okay, they call it, they don't like to use the word ether, but that's what it is. It's an ether. Quantum has the same thing as we always had since the days of the Greek, and that's in mathematical physics, right? And that's discrete particles. And what we're saying is something else. We're saying that all atoms are physically interconnected. So we have discrete versus interconnected. And that's all I can tell you. That's if you can't understand that, there's no use in going further with any questions with you, because until you understand this difference, you won't understand anything. Okay, so yeah, quantum, discrete, Rove hypothesis, our proposal, physically interconnected. That's the difference right there, and we can explain gravity with that because we are connected. We just can't see the mediators. In the case of quantum, they can't see them either, but they use words such as mass and who knows what to try to explain gravitational attraction. Okay. With that, I'll see you next Sunday, and hopefully you had a great Thanksgiving, and we'll have a great Christmas. We'll see you then. Bye-bye.